Hello everyone. Before diving into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription truly makes a difference and helps this channel grow. If you enjoy our content and don't want to miss our upcoming videos, subscribe to the channel and turn on the bell to receive all notifications. In the deep reaches of space, where the sun's light is only a faint and distant echo, an ancient artificial probe continues its solitary journey through the darkness. Its name is Voyager 1, and it is the farthest man-made object from Earth, a silent messenger launched in 1977 that, after nearly 50 years, has crossed the boundaries of our solar system. But what it discovered beyond that threshold left scientists speechless: an invisible barrier, a kind of wall of fire that separates our small solar realm from the vast interstellar space. When we talk about the edge of the solar system, we're not referring to a clear or visible line, but to a transitional zone called the heliosphere, a gigantic bubble of charged particles expelled by the sun in the form of solar wind, expanding far beyond the orbits of the planets. At its boundary lies the heliopause, the point where the solar wind comes to a halt, repelled by the pressure of the interstellar medium. It is here that Voyager 1 detected something unexpected: a sudden rise in temperature and plasma density, a sort of wall of incandescent charged particles. A phenomenon researchers have likened to a cosmic oven. According to the readings from the instruments on board the probe, this zone is not only hotter, but also more turbulent and dense than previously predicted. High-energy particles accumulate here, slowed and compressed, as if held back by an invisible current. Some scientists suspect that the sun itself, through its declining magnetic field, contributes to this energetic stagnation. In this region, the pressure of the interstellar medium cannot fully dispel the sun's influence, creating a sort of friction zone, similar to the shock wave of a ship slicing through water. But the wall of fire is not just a material obstacle, it is also a conceptual threshold. Crossing it means entering a realm where the rules change, where particles no longer respond to the sun's dominion but dance according to older, more pervasive cosmic forces. And in this new territory, Voyager 1 becomes not just a probe, but a pioneer of humanity. It doesn't take pictures, doesn't send photographs. Its eyes are particle sensors, radiation counters, microphones of silence. Yet what it has recorded beyond the heliopause is a hymn to the unexpected. The discovery of this barrier also impacts our understanding of solar protection. The heliosphere, once considered merely an energetic shell, may actually be a true shield against the most dangerous cosmic rays. The wall of fire might act as a buffer zone, a filter that mitigates the entry of violent particles coming from distant supernovae or the galactic center. But what would happen if this barrier were to change, to break, or contract? Some scholars hypothesize that a partial collapse of the heliosphere, perhaps caused by a drop in solar activity, could expose Earth to an unprecedented flow of cosmic radiation, a silent yet deadly storm. Voyager 1, in this context, takes on a role that transcends science. It has become our sentinel beyond the walls of the solar realm, the first human artifact to sail the interstellar seas. And if today it speaks of incandescent plasma and energy pressures, tomorrow it might detect something even more enigmatic: unusual magnetic fluctuations, unidentified radio signals, or even variations in the density of space itself. Because out there, beyond the wall of fire, the physical laws we know begin to tremble. Interstellar space is not a passive void, but a turbulent ocean, made of gravitational waves, millennia-old magnetic fields, and atomic remnants of dead stars. As Voyager 1 continues its journey toward the constellation Ophiuchus, which it will reach in about 40,000 years, we remain listening to its faint signals, increasingly distorted and delayed by distance. Every data packet it manages to send is a fragment of cosmic reality, a message in a bottle arriving from another dimension of space. And it is precisely in this fragile yet powerful interaction that the magic of exploration unfolds. The possibility of touching the invisible, of mapping what cannot be seen, of anticipating mystery with the sole power of curiosity. Yet the mystery doesn't stop at the wall. Moving beyond it, Voyager 1 recorded something that puzzled even the most skeptical scientists. A continuous, low-frequency signal, like a cosmic whisper from the interstellar medium, a whisper unrelated to ordinary electromagnetic emissions. It is not instrumental noise, nor an effect of the probe's aging equipment. It is a constant vibration, a sort of background hum, that seems to come from every direction of interstellar space. Scientists have called it interstellar plasma emission, a subtle echo permeating the region beyond the sun's influence. But what causes it? And why does it seem so regular, so persistent? Some suggest it is the natural movement of interstellar plasma, an invisible sea of charged particles vibrating and colliding in a continuous dance under the influence of magnetic fields as vast as galaxies. Others propose bolder theories, that the hum might be modulated by unknown structures or objects, by clouds of dark matter, or even by signals of non-natural origin. No one speaks openly of alien intelligences, but it's impossible to ignore the suggestion that such a perfectly continuous sound might conceal information, patterns, rhythms still unknown. In a universe where distances are measured in light years and time stretches into eons, even the slightest variation might hold an entire cosmic encyclopedia. And yet, there's something even more fascinating about this discovery. The fact that Voyager 1 can still communicate, despite being over 24 billion kilometers from Earth, is a technological miracle. The signal we received takes more than 22 hours to travel from it to us. It's like speaking to the past, receiving news from a ghost drifting in a forgotten realm. And as its energy dwindles, powered by a slowly decaying plutonium reserve, NASA engineers are counting every bit, every remaining fragment of its electronic memory. But if Voyager 1 is our physical ambassador to deep space, there is also a symbolic ambassador, the golden record bearing the representation of humanity. Engraved upon it, a phonographic disc holds greetings in 55 languages, earthly sounds, star maps, music by Bach and Chuck Berry. It is our business card to the universe. A fragment of Earth, blindly sent into the vastness, in the hope that one day, millions of years from now, it may be found and deciphered by someone else. If Voyager 1 survives cosmic collisions, gamma rays, and interstellar debris, it could become the last object of humanity to exist. When the sun has gone dark, when Earth is but a fossil memory in the system of another star, it will still be traveling. But before that, there is still much to discover. The Wall of Fire is just the first ring in a chain of mysteries. Astrophysicists believe that beyond it lies an even more enigmatic zone, where subatomic particles behave in unconventional ways, and where the structure of spacetime itself may be influenced by galactic gravity. Voyager might even cross the trail of an ancient supernova or encounter a slowly transforming molecular cloud. In these environments, matter behaves in ways we can only simulate on Earth using supercomputers, and which may conceal the secrets of the formation of matter itself. The implications are dizzying. If we could fully understand the nature of interstellar plasma, we might open a new era in physics. Some scientists propose that in these regions we might detect the influence of dark matter, or that models of general relativity might need revising based on the fluctuations Voyager 1 is recording. We might be on the brink of a new scientific revolution, born not in a terrestrial lab, but from a tiny probe launched in 1977, when the very idea of interstellar travel was still science fiction. In this sense, Voyager 1 is not just an exploration mission. It is an act of scientific faith. A universal declaration that humankind is capable of surpassing its limits, of peering into the invisible, of challenging the unknown not for conquest, but for understanding. And every second that its faint radio impulses manage to reach us, every bit we decode from that vast distance, reminds us that we are not just inhabitants of a planet, but navigators of an unexplored cosmos. So, as Voyager 1 continues its eternal voyage, we remain listening. Translating that constant hum, that wall of fire it revealed to us, into knowledge. Because the universe is an open book, but it doesn't speak. It whispers. And for those who know how to listen, those whispers become stories.